Interference water waves are a useful analogy for sound waves. Particles in water waves do not move in the same way as particles in a sound wave, but the analogy helps explain how waves behave. If you dip your finger in and out of water, you can make waves as shown in the picture. If you make two sets of water waves, you can watch what happens when the waves meet each other. If you move your fingers at the same frequency and with the same amplitude, you can make a pattern like the one in the picture. The effect that is produced when the waves meet each other is called interference. Sound waves also produce interference when they meet each other. Interference can only happen when the waves are of the same type. Sound waves can interfere with each other. Sound waves cannot interfere with water waves. Interference is easiest to detect when the waves have the same frequency and the same amplitude. Interference can produce two effects. The waves can reinforce or the waves can cancel each other. Waves that reinforce, the word reinforce means to make stronger. If you look carefully at the picture of the water waves interfering, you can see a pattern. Part of the pattern is made by waves reinforcing each other. These parts appear with waves of larger amplitude than either of the individual waves. In this pattern, there are only small areas with waves that have reinforced. Waves will reinforce when they meet with the peaks together and with the troughs together. If you look carefully at the diagram, you will see that the amplitudes of the two waves that interfere are added together. The frequency of the two waves that interfere does not change. When sound waves interfere to reinforce, the amplitude of the sound wave increases. You will recall from the previous topic that the loudness of a sound wave depends on its amplitude. That means that when two sound waves reinforce, the sound becomes louder. Sound waves can meet and reinforce where there are two sources of the same sound. The picture shows the stage for a music concert. There are two loudspeakers, one on either side of the stage. At certain places in the audience, people may hear sounds of a particular pitch louder than usual. This can be caused by the sound waves from the two loudspeakers meeting and reinforcing. This diagram shows the pattern of sound waves that could be produced from these loudspeakers. The curved lines in the diagram represent peaks of amplitude in the sound waves. Where two of these lines cross, the waves will reinforce. A person at that position will hear a louder sound. Sound waves will also reinforce where two troughs of amplitude meet, but this is difficult to show in the diagram. It is not likely that the sound waves will ever completely cancel so people hear nothing. This is because the sound waves will be reflected off objects, including off people in the audience. These reflected sound waves would add many more waves to the pattern in the diagram, making it very unlikely that only two identical waves will be present to cancel. Waves that cancel. Waves will cancel when they meet with the peaks and troughs together. The word cancel in the context of waves means adding together to make zero. Think of a peak as the wave's maximum positive amplitude, and a trough as the wave's maximum negative amplitude. When you add a positive number to a negative number of equal size, you get 0. For example, 2 plus 2 0. If you look carefully at the diagram, you will see that the amplitudes of the two waves that interfere are added together to become 0. When sound waves interfere to cancel, the amplitude of the sound wave becomes 0. The result is no sound. For two sound waves to cancel completely, their frequencies must be the same, and their amplitudes must be the same. Noise-canceling headphones work by making sound waves cancel. The headphones pick up the sound from the surroundings, then analyze the sound wave and create another sound wave with the same amplitude and frequency, but out of phase with the original wave. This new sound wave is used to cancel the sound wave from the surroundings.
What is the effect called when waves meet each other? Can sound waves interfere with water waves? Interference is easiest to detect when waves have the same watt and amplitude. What are the two effects of interference? What does reinforce mean? When do waves reinforce? When sound waves reinforce, what happens to amplitude? Loudness depends on which property of a sound wave. When two sound waves reinforce, how does the sound change? How do noise-cancelling headphones reduce sound?